If we would like to do hypothesis testing about the population mean given we've got a small sample, here is the test statistic that we should estimate. So T statistic will be equal to the sample mean minus the value of the population mean specified in the null hypothesis divided by standard deviation over the square root out of the sample size. Here on this slide you can get a quick summary of 3 types of tests for hypothesis testing about the population mean given it's a small sample, and the rejection rule. So let's start with the negative tail test. As you can see, the null hypothesis for all these 3 tests is the same, that the true population mean is equal to the hypothetical population mean. And now let's have a look at the alternative hypothesis. In case of the negative tail test, the alternative hypothesis is that the population mean is lower than the hypothetical population mean, and we will reject the null hypothesis and accept the alternative hypothesis when the estimated t-value is below the negative t-value at the significance level of alpha for a given number of degrees of freedom. As for the positive tail test, the alternative hypothesis is when the true population mean is above the hypothetical population mean, and we will reject the null hypothesis and accept the alternative hypothesis when the estimated t-statistic is above the critical value of the t-statistic at the significance level of alpha for a given number of degrees of freedom. And as for the two-tail test, the alternative hypothesis is when the true population mean is different from the hypothetical population mean, and we will reject the null and accept the alternative hypothesis when t-value in the absolute terms is above the critical t-value at the significance level of alpha over 2 for a given number of degrees of freedom. By the way, in case we will have p-value, we know already that the null hypothesis is rejected when the p-value is below the significance level. So let's have a look at the example. A major car manufacturer wants to test a new engine to determine whether it meets new air pollution standards. The mean emission of all engines of this type must be less than 20 parts per million of carbon. 10 engines are manufactured for testing purposes, and the emission level of each is determined. The mean value is found to be 17.59 and standard deviation 2.95. Test if the manufacturer's type of engine meets the pollution standard at 1% significance level. So out of this exercise, we can get the following information. So the sample mean has been found to be 17.59 parts per million of carbon. We also know sample standard deviation, it's 2.95. The hypothetical value, the hypothetical population mean value that we will be comparing with is 20, because we want the mean emission to be less than 20. The sample size is, we know, as 10 engines, and the significance level alpha, we are asked to use 1% or 0.01. So first, as always, we need to formulate the null and alternative hypothesis. So the null hypothesis is always some equality, and in this case that the true population mean is equal to 20. And the alternative hypothesis should be that the population mean is lower than 20, and we know this from this sentence, that the mean emission of all engines of this type must be less than 20 parts per million of carbon. So as you can see, this will be a negative one-tail test. So the level of significance is 1% or 0.01. Since we're working with the t statistic, we also need degrees of freedom, which is calculated as number of observations minus 1, so n minus 1. 10 minus 1, which will be 9. And since it is a negative one-tail test, we get that the critical t-value for 1% significance level and for 9 degrees of freedom will be negative 2.821. In the next step, we calculate the t-value, so we put everything into the equation for the t-value, and we get that the estimated t-statistic is equal to negative 2.6. And now we need to make the decision about the null and alternative hypothesis. we can see that the estimated t-statistic of negative 2.6 is higher than the critical value of negative 2.821, which means that we are unable to reject the null hypothesis. So this is this case. So in our case, actually this one is higher than the critical, so we cannot reject the null hypothesis, which means that at 1% significance level, there is insufficient evidence to conclude that the mean, that the mean emission of all engines of this type is less than 20 parts per million, and that the new type of engine meets the pollution standards. So, in simple words, these producers' engines have the emission that is not lower than 20, which means that his or her engines do not meet the requirements of being less than 20.